All right, we're doing a recording here for these trig graphs, you guys, and I'll probably send you a Google Doc of the finished product. So again, I'm just gonna do this fairly rough. All right, so y equals sine x. And you guys are supposed to go from negative 4 pi to 4 pi. So I'll try to do that here. Here's 2 pi, here's 4 pi. Now the range is going to be from negative 1 to 1. So here's pi, pi over 2, 3 pi over 2. There's 3 pi, so there'd be 2.5 and 3.5. So here's pi, and here's 3 pi. So at pi over 2, we're at 1. At 0, we're here, pi, 3 pi over 2. So those are the 5 key points off the unit circle. And you have one cycle. Now let's do another cycle. Again, the 5 key points. Now let's say I go back here to negative 2 pi. So here's negative pi, and we want to go halfway there again. So this is the same as 3 pi over 2, negative pi over 2. Here's negative pi. Okay, at 3 pi over 2, you're up here at 1, negative 3 pi over 2, and then here. So that's how you're going to do the sine curve. Now, domain, all reals, you could write negative infinity, positive infinity, range negative 1 less than or equal to y less than or equal to 1, just like that. All right, y equals cosine x. Okay, again, four pi, 2 pi, pi, 3 pi, so we got to split these into fourths again. So cosine starts at its peak at pi over 2, 0, pi negative 1, 3 pi over 2, 0, 2 pi, one cycle. Okay, again, at 3 pi, it's at negative 1. I wanted to make a slash there. So then it goes like 2 cycles. If this is negative 2 pi, so here's negative pi, we got this situation here again. So again, at the odd pi over 2's, we're looking at where it's 0. So domain, negative infinity, positive infinity, range again, negative 1 to 1. Okay, tangent graph. Now here the period is pi, so we're only going to go from negative 2 pi to 2 pi here. So when I start looking at this, okay, if I put 2 pi out there, then here's pi over 2, 3 pi over 2. Okay, here's 1, 2, 3, and so on. Now the tangent of 0 is 0. Tangent of pi over 4, which would be right here, is 1. The tangent at pi over 2 is undefined. So at pi over 2, you have an asymptote. Same thing at 3 pi over 2, you have an asymptote. Okay, so this thing goes up like this and gets closer and closer. Now from pi over 2 to pi, you're in quadrant 2. The tangent of pi is 0. The tangent of 3 pi over 4 right here is negative 1. So this thing's going to look like that. So there's one cycle. Now, again, what happens in quadrant 3? It's positive again. So this thing at 3 pi, at 5 pi over 4, so it goes like this. And then at 2 pi, again, it starts going like that. So in the fourth quadrant. So there's one cycle. So if this was negative 2 pi and this is negative pi, here's the negative pi over 2. There's your asymptote. 3 pi over 2, there's an asymptote. Tangent goes like this. It's going to go like that. So there's 2 cycles of the tangent curve. Actually, 4 cycles. Okay, what happens with y equals cotangent x? Okay, now cotangent's the reciprocal of tangent. So it's undefined at 0. So you got, so if this is 2 pi right here, and this is pi, and we'll go negative pi, negative 2 pi. All right, the tangent of pi over 2 is 0. At 0 and pi, you have asymptotes. Tangent of pi over 4 is 1. The tangent of 3 pi over 4 right here is negative 1. So this thing goes like this and like this. Okay, again, here's 3 pi over 2, 0. And this thing's going to go, again, here's quadrant 4, so it's positive. So 3 pi over 2, 0. And again, here's quadrant 3, so it's positive. I said quadrant 4, I meant quadrant 3, it's positive. Here it's negative, asymptote. Okay, again, over here, asymptote. Pi over 2, 0. Quadrant 4, it's negative. There it is. So this would be quadrant 4, quadrant 3. And then again, you have another cycle right here. So y equals cotangent x. All right, y equals cosecant. So we're going to start out by lightly tracing in the sine curve. So again, I'll put, well, I'll just try to blow this up. So I'll just do one cycle here. And we'll do a cycle over here. All right, so I'm going to put the sine curve in first, just the dots. So where we have a dot at 0, you're going to have an asymptote. Asymptote at 0, asymptote at 0, asymptote at 0. Okay, so the reciprocal of 1 is 1. Okay, so sine normally, if I play the dot to dot game, it looks like this. And you do it over here, same thing, dot to dot game. So now your cosecant graph is going to be like this and like this, and again, asymptote, asymptote. So it looks like that. Okay, domain. Okay, all reals except n pi. All reals x does not equal n pi. Okay, range, it's greater than or equal to 1. So it goes from negative infinity to negative 1, inclusive, or, which we use this union symbol, from positive 1 to positive infinity, just like that. And I'll give you a copy of this. The last one is the secant graph. So we trace the cosine. So cosine starts here, pi over 2, pi, 3 pi over 2, 2 pi. So lightly trace that. Excuse me. Okay. All right, so wherever this is 0 now, at the odd pi over 2s, you're going to have an asymptote. All right, the parabolas are going to go like this, and like this, and then halfway there. And this one's going to go like this, and like this. So there's from negative 2 pi to 2 pi, and you guys have to go negative 4 pi to 4 pi, so just graph those. So that's how you graph the 6, and again, the domains and ranges, and I'll put a kind of like a key on the Google Classroom, a copy of how these should look really nice. All right, I'm going to stop the